GCSE Physics, IGCSE Physics, Year 10 Revision Review. Springs, wires, and other things that temporarily deform in shape when you put weights on them. There were two great scientists at the time. The boss was called Mr. Hooke, and the new guy was called Newton. And Mr. Hooke spent most of his time looking through microscopes and drawing what he saw. Tiny little insects and stuff, mites, the sort of ones that live in your cheese. Cheese nights. Have a look on YouTube. That was the start of Hollywood movies. Was a 5-minute movie about looking down a microscope at mites. Yeah, people would go and watch it 10 or 12 times. So that was the first big movie hit for Hollywood? Well, movie hit. Mites. They're on people's bodies, they're on people's food, they're crawling around the ground. They're a large part of the biosphere, of our ecosphere. Mites. Oh, yes. But Hooke also, and this is what he got famous for in the physics side of things, he also put weights on springs. And he noticed that when you put a weight on a spring, it gets longer. No real surprise then. But what he did was the mathematics. Physics is always about that mathematics. If you double the weight, the longerness is doubled. This is called the extension. This is called the original length. So the spring starts with no weights on it. It's this length. You put 100 grams on, it goes 1 centimetre more. Take it off again, goes back to shape. Put 200 grams on, double the extension. And so this became Hooke's law. And so he did graphs of extension against mass. Strangely, the extension was on the x-axis and load, or mass put on, was on the y-axis. Usually it's the other way around with the independent and dependent variable. Independent being extension in this case, and dependent being the load. Anyway, he got a straight line. Brilliant, he got famous for this. It also works for wires and everything metal. It works for glass as well, but the extension is so small that it's difficult to measure. Things it doesn't work for is elastic bands. In elastic bands, you get a hysteresis loop. Hysteresis? Yeah. It's a weird curvy thing and doesn't work for that. So you get a straight line, you keep putting weights on, and eventually this straight line stops because the atoms, rather than trying to push past one another, giving you that straight line, it gets to the elastic limit where it actually does put past one another, and you get movement of the atoms. And this is called plastic behaviour. The word plastic means that, your plastic clothes, and your plastic pen, your plastic ruler, and quite a few plastics around your house, when they're made, they're heated up and they're squashed into shape. Squashing into shape is plastic behaviour. So squashing into a new shape is what happens to a spring when you put too much weight on it and boing, it won't go back to its original length. And so the straight line graphs go boing, and then eventually you put much too much weight on it and you've just broken my spring. You go beyond the elastic limit, and I can't use that spring for an experiment again. Thanks, don't do that. Bring your own springs. The springs inside your pen will do. Yeah, and lots of springs that you can buy, unfortunately. They give such a small extension that it's hard to measure and hard to make the graph. So science suppliers give springs that are easy to measure. You just put them next to a ruler, add the weights, and take the measurements off a ruler. You can find out the extension. Extension against original length. That's my lesson for today. Good luck, guys.